Okay, so today we're in lesson 1-3. What's a widget is the title of the lesson. Okay, so if you look up there, I have some pictures.
It's kind of confusing.
There's a widget. Okay.
That's odd.
Then there is not a widget.
Oh, I get it.
So of those four, which are widgets? So based on the diagrams that they have. So you know everything here is a widget. This purple, blue, green, and red. This is not a widget. This purple, yellow, white, and brown. So down here, A, B, C, or D, which of those are widgets? And justify your answer.
A and C.
A is a widget.
A is a widget. Why?
Because it has the two different little arm fingers and it doesn't have a shape in
It has the two different little arm fingers. Okay, basically I think she means the arms here, the one with the circle with the arm, and it has nothing inside. So A, I would agree, is a widget. Is there anything else that's a widget?
No.
No.
B is not a widget. Okay, it's got the two arms, but notice it doesn't have the arm with the circle. C is not a widget. Why?
Because it has something inside.
It has something inside. Very good. And is D a widget?
No.
Okay, so A is a widget.
That's weird.
So what we're going to do, okay, is we're going to talk about good definitions today and how important it is that you are very clear and concise when you define something. And so a counterexample is an example that shows something to be incorrect. So basically, a counterexample is when you're trying to prove something is wrong. You probably do this with your parents. You try to prove that they're wrong, so you give them a counterexample. Yeah, but you let me go last week. Last week I got to stay out till midnight, and now you're telling me I can only stay home till 11. So you're giving them a counterexample. A counterexample is an example that shows something to be incorrect. And so, what we're going to kind of do here down below, don't write down that everyone knows yet. Okay, this is an activity we're going to do in class right now. Okay, everyone knows a square is a figure with 4 equal sides. But what's wrong with this definition? So I want you to think about that definition. Only that definition, not anything else that you know. Only based on the fact it says a square is a figure with 4 equal sides. Sketch a counterexample. So does anybody have a counterexample to that definition? Got one?
Diamond.
Okay, go ahead, write it up there. Here. Because there's actually quite a few different ones. Okay, so we got a counterexample coming up here on the board. There you go, good.
Oh, oops, I got it.
No, that's okay.
It does.
Well,
No.
it wasn't.
I know exactly what you're thinking there. Okay, so now the difference here is that, okay, we know this has 4 equal sides, but this is not quite a square. I think what,
Yeah.
okay, this is kind of what I think maybe you were going for. Okay. Anybody got anything else? I got a thought for you.
Oh.
You got one?
I think I have a really shot maybe. Oh. I get
Could that be a figure with 4 equal sides?
Mm-hmm.
Yeah. Notice
Also-
the definition. The definition does not say it is a 4-sided figure. The definition says a square is a figure with 4 equal sides. We already know that these last 2 figures are not squares. So you see how important it is that we have a good definition. Okay, we have to be very clear and concise. So let's think about that. What could we do to make this definition better? Yes, sir.
A square is a figure with equal sides and equal angles.
Equal sides. Ooh, that one would work. Let me see if I got one here. Nope, I don't have one here, so we're going to go ahead and write that down. Okay. A square is a what?
A square
is a,
Figure with 4 equal sides and 4 equal angles.
okay, 4 equal sides and 4 equal angles. Do we have a counterexample for that? Ah, could this have, if I had equal angles here, would that be, that would have 4 equal
They're all
angles.
right angles.
A square is a, let's specify. You said a square is a figure, but let's even, a four-sided figure. A four-sided figure, okay, and eventually we will learn that a four-sided figure is actually called a quadrilateral. Okay, a four-sided figure with equal sides and equal angles. Now we'll eventually learn about a square. So it's not like we're going to discuss a square here. What we are discussing is we are discussing how important it is to have a good, clear, and concise definition. So that's going to be our topic today, clear, concise definitions. So now what we're going to do is we're going to look at this. Beginning steps to creating a good definition. First thing, you classify your term. What is it? Oh, check that out. A square is a four-sided figure. We had that. I didn't even know that was coming. Okay, number 2, differentiate your term. How does it differ from others in the class that has 4 congruent sides and 4 right angles? Test your definition by looking for a counterexample. Okay, so now if you look at this one, the same number of arrow marks indicate that lines are parallel. The symbol with the 2 vertical lines means is parallel to. That should be review. We've discussed that, about what parallel lines look like. So in this case, I is parallel to J. Okay, you will also see parallel lines indicated with these. Okay. A small square in the corner of an angle indicates that its measure is 90 degrees. So that means that all of these angles are 90 degrees. And the symbol, the upside down T, means is perpendicular to. Remember, perpendicular means they meet at 90 degrees. So in this case, it says line K is perpendicular to line L. All right? So what we're going to do is we're going to define the following terms. Parallel lines. What can you tell me about parallel lines? Yes?
They run forever, run straight line, and never cross.
Okay. So let's kind of try and, first of all, we know they're never going to cross. What else do we know about parallel lines? They never end. Okay, what else do we know about parallel lines?
They stay the same distance apart.
Stay the same distance apart. So parallel lines. Lines that do what?
Never try to turn the same length apart.
Okay. Now, I want to think about something here. Okay. We're going to think about 3 dimensions here. Okay, so 3 dimensions. So, I want you to think about parallel lines. Would one of the lines on the ceiling that goes this way be parallel to maybe a line that goes this way on the floor? Maybe this, here, let's do this wall. Okay, the bottom of this wall, and then let's go with that along the ceiling. Are those going to be parallel? No. So we have to specify a little bit more.
And in the same direction.
Lines, they have to be
On the same plane.
on the same plane. So lines that are coplanar. So lines that are coplanar, or you could even put coplanar lines. Okay. So lines that are coplanar that never meet. So if you have 2 coplanar lines, do I need to specify that they stay the same distance apart? No, because if they're coplanar and they never meet, they will have to stay the same distance apart. All right, perpendicular lines. All right, what about perpendicular lines? What do they do?
The same thing that intercept.
Okay. Okay, so let's think about that. Let's imagine this part of the wall. And let's imagine one of those lines that's on the ceiling. Would those be perpendicular?
that line headed straight up and nothing.
Yeah. Isn't that perpendicular? Yeah, so do they have to be in the same plane? No. So they're just lines that meet at 90-degree angles. So those of you that really like to argue your point and debate should do really well at some of this stuff. Okay, now we're going to talk a little bit, if you remember when we first talked about parallel lines, I gave you the analogy about the part in the wall here and then the part on the ceiling that went. Okay, we actually have kind of something else that you maybe have never heard about, and that's what our skew lines. Skew lines are an example of that. They are two non-coplanar lines that do not intersect. So that would be the baseboard, and that would be the part on the ceiling that goes. Those would be skew lines. They are two non-coplanar lines that do not intersect. Okay, so we have parallel lines, perpendicular lines, and skew lines. Now what we're going to do is we're going to kind of do an investigation. You guys are going to do that in class right now. I'm going to go ahead and stop the video and we'll pick up on it again. And if you go to page 49 and page 50, here's what you're going to do. They are going to give you some examples and non-examples of angles. And you might already know the definitions of these angles. Okay, so it might be fairly easy. You are going to write a definition for each bold-faced term. Don't write it in the definition part of your notebook because I will give you the correct definition afterwards. So just kind of talk and figure out what a good definition is. You're going to trade definitions, test each other's definitions by looking for counterexamples. If somebody finds a counterexample to one of your definitions, write a better definition. As a group, decide on the best definition for each term. As a class, we'll agree on common definitions, and then we will add these to your notebook. Okay, so we're going to go through those. The right angle, acute angle, obtuse. All of these up here are what you're going to have to define. They give you examples and non-examples on page 49 and 50 of your book. Okay, so we'll pick up the video after you guys are done with your investigations.